Time is 3 o'clock. Let us start on time. And once again, on behalf of MTC Global Family and IIIE, I welcome all the participants in our day 2 of intermediate certification programs. We have with us our respected resource person, Dr. Mitra sir and Dr. Banerjee sir. They are already with us, and I request Mitra sir to kindly please take over the session. Thank you.
Yeah, thank you. So, am I clearly audible to all of you?
Yes.
Yes, sir. Audible.
Okay, thank you. So, once more, please confirm whether my slide is visible.
Yes.
Visible, sir.
Okay, so thank you. Thank you for confirming. Today, what we have planned to discuss is that the popular AI frameworks with which we will be developing and deploying AI tools and software for production or for research. And at the same time, we will continue with the practical exercise that we are doing on regression that will be covered by Dr. Banerjee as well. So if I get time after discussing this AI frameworks, I will start discussing the concept of artificial neural network, because that is a major area in deep neural network as well. So in between, if you face any kind of difficulties, you can always means give your opinion. You can ask questions such that we can discuss and make the things clear. So as part of the curriculum, so in the second day, we were supposed to discuss the AI frameworks. So first of all, what is AI frameworks and why it is needed to be discussed? Because from the previous few discussions, we found that this artificial neural network or overall artificial intelligence involves different domains and directions from mathematics, statistics, and all. So we need something to bring all these things under a single umbrella. Why? Because nowadays artificial intelligence is not just a kind of a area of research or something like that. It's now a kind of a thing. It is now like a technology which is now being widely used almost in every industry, and obviously for almost any kind of problems we are actually applying this type of frameworks, this type of AI tools for our ease, for our efficiency and all. So the thing is that understanding and discussing the things in pen and paper, or just writing a simple code through any particular compiler or browser or an interpreter will not be sufficient to bring any particular technology deployable. So for that particular purpose, we need some frameworks which will be helping us to easily develop the AI models and deploy it for directly for means our own purpose. So for this particular things, we basically have three different layers. So basically, in this particular tower, you can find that the ground floor means the very bottommost layer involves some hardware and mathematics. And hardware, we all know that here actually the GPU, CPU is the most important part, obviously, with other already existing hardware for computations. Those are actually used like RAM, other kind of a thing. Okay. Now in the middle layer, what we have now is the frameworks and libraries. So this middle layer will help us to accumulate, to bring all the different algorithms, mathematical formulas, the mathematical like what I call interpretation and representation in a particular single umbrella, and we call that to be a framework or a library. So I will discuss that why there are so many different languages out there through which we can develop like AI tools or AI algorithms we can implement. But still, the Python is the language which has become most popular one. Okay, for developing this type of solutions, AI solutions for industries. Why? Because of its wide availability of different types of libraries, which has made different tasks very easy to understand, very easy to implement and deploy as well. So in the middle layer, we are having the frameworks and libraries, and at the top, where actually the application means this is the place through which we actually interact with the end users. So this can be a web app, this can be a mobile app, kind of a thing. So this is where, so this is the hardware frameworks, there's libraries and frameworks and the applications. So these three are the main building blocks of any kind of frameworks, and all of these three need to be integrated smoothly and easily such that the overall implementation and development become easy. So how these things are achieved, and what are the why this framework is required to be discussed, and why Python. So these answers we will try to find over here. So earlier, for any kind of problem, we all know that manual logic used to be the option, and for any kind of reasoning or something like that, people used to use symbolic reasoning, or it may be earlier for knowledge representation and for knowledge, what I call derivation of reasoning. We had different options like simple rule-based systems. Other than that, we had semantic network that still we use for different hierarchical informations. Okay, from in biology as well as some other places as well. So semantic network was an option for representing knowledge and deriving knowledges. Then other than that, we used to have frames. Okay, we used to have scripts. So these were the different types of knowledge representation mechanisms that we earlier had, and people used to derive or represent new knowledges from those kind of a thing. Okay, so at the time, the intelligence what we used to understand to be intelligent was solely confined to the like those knowledge engineers, developers, or simply if I talk about there are programmers. So none other than the programmer had an access that what is the thing happening inside, kind of a thing. So after that, from 1980s till 2000, we had received some means high level programming languages, so like C, C++, Java. So with the help of those, we used to develop logic in some algorithmic manner, some well-defined manner, and with the help of loops and subroutines. So these had made implementation of all kind of logics basically very easy to understand, and it has made more powerful as well, because we have a lot of details that we can interact, and we can change, we can customize according to our own need. So basically, this is the era when memory management from we shifted from memory management to some algorithmic logic. Okay, so we used to have like a procedural programming language. We used to write code, modular codes or something like that. But now that were also very much abstract, means what I call this was understood mostly by the programmers or the expert in that particular domain. So to understand or to implement any kind of a large algorithm or a large logic, little complex one if I'm talking about, so that particular person had means has to have actually means a long experience, a vast experience in programming. Why? Because it was fully coding dependent. Each and every line of code was important at that time, and for a simple particular change, a different portion of the code needed to be changed, and understanding and keeping track of whole code was a very expertised task. So at the due to which means software was solely like what I call a responsibility, or what I can say that the field of mostly the computer engineers or the developers or the coders. But that concept was gradually started to means vanish. Why? Because with the advancement of more efficient programming languages, tools, rather I will call frameworks. So this has made the things revolutionized, because when the framework came, we means what I call the necessity of understanding the code in for more detailed point of view was removed. So without understanding the code in much details, in the granular details, still see, whenever I am implementing any kind of algorithmic logic, obviously hardware level, ultimate the thing is that we have to interact with the computer hardware as you used to do earlier. So here today also the things are happening. And for that particular efficiently managing the hardware is still a very good option is C and C++. But it's very always very difficult to interact, to write those complex code with the help of C and C++, because that is very expertized task to do. But for the modern engineers or like developers, now with the availability of frameworks, without knowing or understanding that granular level of details of C and C++, we can write and develop, we can interact more effectively and efficiently with the hardware and implement our own algorithms for our own purpose very easily. So framework is giving us the abstraction of without knowing the granular level code, the detailed code. Obviously, still we have to write the code, but not in that particular detail that we used to write in C, C++. So that particular thing is now being made abstract or made easy by this framework. And one of those, like what I call that community that provides us this beautiful and most powerful framework with which we can develop most of the AI algorithms deployable for directly for real life problems solving through web applications or through edge or through mobile app or somewhere is easy for people, for most of the organizations, is Python. So Python is that particular community which is means strongly focused in this particular area and leading in this field of artificial intelligence, overall machine learning, deep learning, whatever we are saying. So especially this framework has become indispensable and most important whenever we are dealing with deep learning. Okay, because deep learning is is very complex and broad part. A lot of different directions are there which combinedly provide you the full solutions. It requires means algorithms from a simple linear algebra like vector calculus, matrix, like that. It also requires optimization, okay, like gradient descent and all for error minimizations. Okay, so this is required on a part, and it also requires calculus for back propagation of error. I'm talking about in multi-layer perceptron artificial neural network. So three different types of mathematics we need to deal with all the time for each and every pass or what I call epoch or iteration whenever we will be training any particular deep learning algorithm. But for each and every time, if you have to minutely check that how the hardwares are being integrated, how the memories are being used, or like instruction sets are being written that you used to do with the help of C and C++. So that will be very cumbersome, very huge, and very difficult for us to keep track of. So that particular detail is now being taken care of Python. So Python is giving us a framework in terms of like what I call TensorFlow and PyTorch that I will come later on, through which we will be mainly focus on the basic building block of deep neural network, like how many layers are there, what type of optimization algorithm we will be using, what type of how the layers will be managed, how the errors will be backpropagated. So this broader level of abstraction we have to take care. But how after that, how the things will happen and managed at the hardware level, so that's not our concern, because that responsibility is being taken by Python itself with the help of this framework level abstraction. So this is where the framework is very much important, has become important for us. So in this 4 layer, we know at the very bottommost layer, we have infrastructure. There is computing infrastructure like GPU and TPU. We all know that with the advancement of GPU and TPU, we have achieved huge parallelism. Okay, and due to which only because of this particular hardware, GPU and TPU, the whatever the deep learning and Gen AI that has become a reality today. So if you didn't have this kind of hardware, I'm quite sure this was not going to happen so fast and so early, because the type of computational load that we will have whenever we will be training a deep neural network for a large scale problem will be very difficult to manage with the help of CPU only. Okay, so after that, above that, we have the data layer, where we actually keep the data as input, like we have data ingestion, vector databases, pre-processing. So for this particular, we need different libraries from any whatever the programming languages we are using. Now, yesterday, Dr. Banerjee was showing you that the use of the library pandas, we will be using the libraries NumPy as well. So why those things are very much important? Because whenever we are taking that an Excel as an input, and you are finding that that Panda library was making those things as a matrix like structure very easily, and from that you were able to visualize it, manipulate it, doing everything. So now, if you can remember, those who are familiar with C and C++ programming languages, they can easily remember, just to take a matrix as input, we had to use a two-dimensional array. So you used to sometimes have to multiply two matrix, or to add two matrix, we have to use multiple nested loops for doing that. And the simple, just to define a matrix, taking an input and multiply two matrix, we used to have more near about 100 lines of codes in C or C++ for doing that. But nowadays, now with the help of this Python library, and we can just do it in a single one or two lines. So this is how the abstraction has taken place. This is what the advantage here, because our main focus will not be the minute detail of the coding. Our main focus will be just to solve the problem. So why should I bother about that? So less focus on the syntax and coding, more focus on problem solving, what I call customizing it, tuning it, so such that my performance of the model has become. So this is the goal. This is the goal the data engineers should have with the availability of so many tools. So that's why day by day the community is trying such that the coding becomes easy, because it should not be the case that only people from computer science or IT background should be able to do coding. No, coding is now I'm telling you, I'm not means ambitious here in this particular sentence. You, all of you, irrespective from whichever domain you are, if you have little bit of interest and some kind of time, some amount of time you can devote, you can learn this high level of abstract coding with the help of Python very easily. And once you have learned it, then you will be able to understand its power and strength, and how much effective it is, because at that particular time you will be able to solve any kind of problems with the help of these different algorithms and all. So data layer, and then after that we have the model and frameworks. So particular frameworks, we require some orchestrations, okay, which will be doing means combining the different mathematics algorithms in a single place. So for that particular purpose, we have PyTorch and TensorFlow, the most popular frameworks for deep learning provided by Python community. Okay, but this is not enough, because we will not do the coding in VS Code or in Jupyter Notebook or something like that. No, because whenever we will be deploying any particular thing, it should be deployed through some kind of like either it may be a web browser, it may be a mobile app, or it may be an edge device, isn't it? Because users will be directly interacting with your tool through these interfaces only. So for that particular purpose, whatever models or frameworks of models we have developed, the algorithms we have developed, so that should be deployable. That should be placed in such a way like everybody will be able to use that particular strength. So that is actually the application layer that we talk about. So 4 different layer: infrastructure, data layer, model and framework, and application. Infrastructure, obviously, you need to have before you start developing any kind of deep learning or machine learning project. And data, you must be ready, you must have the raw data ready with you before you move or search finding or whatever, developing any kind of new algorithm, or you are going to modify any kind of old algorithm, whatever it is. So data. So once you have received the raw data, then Dr. Banerjee was showing you yesterday that how you can visualize that particular data. So never jump into the algorithm directly. I'm repeating over here. So those who are familiar with development of this machine learning and DL algorithms, they know it very well. So now it has become a normal tendency among the students because they have the GenAI tools, they have the VS Code live what I call Copilot or something like that, which has made coding just like a, means what I call just a game, just simple thing. Within a flash, the whole code is being written within seconds. So it has become dangerous. One way, this is very much required for those experienced engineers, because for them it is the main focus should be on concentrated on the problem solving, the pipeline, because for them coding is very much irrelevant, because they know coding, they understand coding. So why they should waste their time for writing the syntax and codes? Mainly they will focus on that. But whenever students are getting this kind of tool with them, so they are not bothered about how the syntax and written, how the logic is implemented. They are doing trial, and whatever the code is being generated by AI, they are just copying it, pasting it in some kind of interpreter or compiler, checking it, whatever what is coming, whether it is correct or not, still they are not able to interpret. So that should not be the case always. So we should properly visualize the data and have some kind of analysis or brainstorming based on the exploratory data analysis results that we have received before directly go for applying any kind of regression or classification or any kind of AI algorithms into practice. Okay. So this is very much important. And application, I'm very much frank about this. Earlier, just 2 to 3 years ago, people have developed a lot of things till that third layer. So we normal researchers or normal, what I call the persons from academics, or those who are means fond of doing coding and developing or problem solving, they used to do like up to the third level. So developing any kind of model and software, but fully means based on that interface or a compiler or interpreter. But just developing a website and installing or hosting your algorithm or the software directly into the through web pages and making it available for public with the help of these web pages, means web app or mobile app or edge, that used to be a kind of a complex task, because a lot of different things has to be involved. But again, with the advancement of Gen AI on LLMs, uh, these things has also become very easy nowadays. Developing a website, developing a web app with the help of any kind of framework, many frameworks are there, like Flask is there. So, and integrating your algorithm, ML algorithm into it, such that you can develop a very attractive web app. Because if I demonstrate any particular algorithm with the help of VS Code and command prompt, it looks very odd. Means if people don't get interested, whatever may be the power and strength of the algorithm. But if you provide a interface, a very colorful, attractive web interface, and people upload their data, tune their models, whatever it is, with the help of buttons and text box or whatever the drop down or something like that, it will become more interesting. So so whenever nowadays, if you develop any particular algorithm for your client or any particular ML model for your client from other domain maybe, and you would like to showcase it, demonstrate it, so and obviously you are not willing to do the same with the help of command prompt and this coding interface and coding window and the things that are happening in command prompt and downloading and showing. In spite of doing that, you just create a web application, a web interface, integrate your ML model, and showcase or display. It will become more attractive and more convincing. So it has also now become very easy with the availability of GenAI tools. So why the framework was actually required? Because I was saying that simple deep learning model, it requires different domains of mathematics and science. So basically, it requires linear algebra, to represent the data. It's basically known as the geometry of data. And then so calculus is required, because the error has to be back propagated. I will discuss later on whenever I will be discussing the artificial neural network, because obviously one shot after developing a model, in the first very iteration it will give a prediction. Now the prediction may not be, it should not be accurate enough exactly what is actually the actual. So there will be a difference between a predicted value and the actual value. So this particular difference is known as the error. Now these error, we have to tell back to the network or the particular model that this error is now generated. Whatever you have done, this error is now generated. So I am giving you back this error, and you modify yourself such that in the next iteration the error is minimized. So this is actually sending this error back to the model through different layers is known as the back propagation. So this back propagation means sending this error back to the particular different layers of the model and asking it to change itself slightly such that in the next iteration error is minimized. So this is actually is known as the gradient descent. So you need to calculate the gradient based on the particular error. What are the models or parameters? What are the parameters of that model were responsible in generating that output needs to change themselves such that in the next iteration error is minimized. So gradually this error need to be minimized. So for that particular purpose, we need to find the gradient. Okay, so like simple dy dx. Y is it the error? So how that error is being changed based on particular x or the particular parameter value, I will discuss. So this is where the calculus is very much required. Okay, and this each and every layer, that gradient has to be calculated. The layer will be back propagated, and then again in the next iteration, again a forward pass will be there. That means again a new output will be generated. Now we will check again whether that output is nearer to my goal or the actual value, or I'm going far from that. So again that error will be passed. So these things is a cycle. It will continue iteration wise. So until we get a satisfactory outcome and error is minimized, this whole process will continue. This is what we actually know as training. Okay, so this is where the calculus is very much required. And whenever any output for suppose any classification, most of the cases, whenever we are predicting any particular class based on some data, so the model will give you the outcome based on some probability. Okay, so a probability will be attached on any particular outcome. So any particular data set which is given as input will have a probability. Suppose my problem is classification, and I have two class to be predicted. So it's a binary classification problem. So in that case, every data point will have a probability. That what is the probability? How much means likely it is that it will come under class A, or how much likely it is that it will come under class B. So it will have a probability. So based on that probability, I will decide that in which class it will go. So normally the thing is that if it is more than 0.5, suppose, it will go to class A, and if it is less than 0.5, it will come to the class B. So this is where the probability is very much important, because probability will be deciding the output finally, that which class it will come. And here a lot of different functions are used, like a softmax function or something like that, which is actually working on this particular probability. So this probability is the another particular part. And I have already mentioned that a gradient optimization, that error should be gradually minimized such that my model means what I call approximate the function better, and gradually my error is decreased. So these four important different dimension: linear algebra, calculus, optimization, probability. So these are the things. So we need something which will be taking care of all these things by its own, because for a particular problem, I know that these things are required. I also know that how these things are actually work in my model, but still it is very difficult, and what I call like complex thing that for each and every iteration I need to manually keep track of all this particular thing with the help of loops and tuning and parameters. So these things actually, framework, any particular framework will automate all these things. That particular linear algebra, calculus, optimization, probability, whatever the different roles and responsibility will be automated. So we, the users, the basically coder, will not have to bother much about these particular things individually. This is the need. Okay. Now, different libraries or different tools are already available in the market nowadays. Okay, so for simple classical machine learning, one library is very important and most popular one, that is scikit-learn. Okay, so that is again provided by the Python community, and it is, I will say, it is the most suitable tool for any kind of machine learning algorithms. So it may be classic supervised, it may be unsupervised, it may be classification, regression, clustering, PCA. Every algorithms are already inbuilt in this particular library. Only you have to know that how to use those algorithms, how to fit your data in that particular algorithm. It will also give you the output. Now, how to interpret that particular output, how to how to understand that particular output, how to deploy that particular output, it is up to you. But you do not have to much understand the mathematical logic or the formula that is behind those algorithms. Like I can easily apply support vector machine if I know that which particular function from this particular library scikit-learn actually implement support vector machine, and what are the parameters that I have to pass, what are those parameters I need to pass, and what are the parameters I can tune. If I know this, you will be getting, you will be writing means without preprocessing part 2 or 3 lines of code just to implement this support vector machine, and you will be getting directly the output like a classification or regression, whatever it is, with the help of that. So this scikit-learn is a so much sophisticated, powerful tool, and it's very fast also. Okay, through which we can implement any kind of machine learning algorithm. So for deep learning, I'll come to it later. Now, for already, those who are not fond of like coding, or actually are afraid of doing coding, so though it should not be the case, I personally telling all the participants, because you are from various different backgrounds, but you have quite good experience. So those you are from science or arts or commerce, it doesn't matter. Those who have a sense of logic, like this, if this happens, then this will happen. Simple logic. So they can understand the code and they can do coding very easily with the help of combination of few tools that Dr. Banerjee or me will be discussing that later. That how without understanding too much details of coding and mathematics, you can develop a beautiful means models very easy. So in our previous session, we have discussed about this Altair AI Studio, if you can remember, for this no-code AI tool, and we found that how without knowing a single line of code, we were able to implement decision tree algorithms. So not only the decision tree algorithm, you will be able to do any kind of machine learning algorithms without writing a single line of code with the help of this particular tool. So AutoML is another option. Okay, so this is a no code tools. So this again has become a good option for the researchers or professionals from various different domains. Try AI without knowing much of coding. Okay, just understand the algorithm such that you will be capable of interpreting what is happening and what outcome you have received. So this is very much important only. Okay, so this is, so other than that, for deep learning, this is a little bit complex one. I won't say that this is very easy, but you need some kind of study to understand the different components and different layers and the pipeline through which these things works. So in deep learning, we have different options like multi-layer perceptron, for classification and regression. For image computer vision, we have CNN, that is convolutional neural network. For sequence data processing or problems which deals with sequence data, we have means RNN. Okay, so recurrent neural network. So these different options are there. Now we have transformer neural network, which is actually working on that particular previously said one. And other than that, we have a generative adversarial network. We have graph neural network. So these are the different tools which are more sophisticated to some specialized area and very powerful. Okay, so but for complex real life problem, we need those particular tools or model to be understood before those are deployed. So for deep learning, I will say a little bit of study or understanding is required about how these algorithms works. Once you have understood it, okay, the things that are happening in this way at the broad level, and these are the logic or mathematics behind it. Now implementation, which was not earlier possible. I'm telling you, yes, not possible, because if possible, we will show at the very last session that writing a simple multi-layer perceptron with the help of PyTorch or TensorFlow library has become a very easy thing. I think maximum it will take 20 to 30 lines of code, and a full things can be done very easily. But if we have to write a simple Python code, forget about C and C++, simple Python code from the scratch, it is very complex and very means huge code we have to write. So this is where Python community has thought that this power of deep learning should not be confined among this computer science people only, or this in this domain only. So that's why they have developed TensorFlow and PyTorch and Keras. For what? For just wide applications. So people from any kind of industry actually prefer this first one, TensorFlow. I will come to this later on because this is very easy to implement, easy to understand, easy to deploy. And for the researchers who need to fine tune their own algorithms, have to little bit modify its parameters, have to change some particular specific sub module of a particular code, manipulate it by their own, check what is happening deeply inside. So for them, PyTorch is the library which they prefer. And Keras has made there's a third one, has made this industry deployment more easy. So it actually built on this TensorFlow, but has made the deployment like means you will not feel any kind of difficulty or complexity whenever you will be developing any kind of deep learning model with the help of Keras. Okay, and for inference and deployment, the fourth one, because it is not end word here. Okay, so any particular developer or researchers have developed a tool, an algorithm which is working very fine, but how to make it available for the user or for the higher management. So for that particular purpose, you need to host it into particular web server or edge server or mobile server anywhere. Okay, so for that particular purpose, these tools are very much important, that inference and deployment tools. So any doubts so far? Any question from the audience?
Sorry, just coming out of mute. In the previous slide.
Yes.
What exactly does the inference and deployment do?
So see, inference and deployment means you have developed your own model and algorithm. Okay, it may be suppose a regression model. Okay, which will be where you need to provide a data and it will give you the result. Okay, now it is working in your own computer, in your own laptop. Okay, but suppose you are from a sales industry and you will be doing some kind of a sales focused, and that particular model will be used from people from different hierarchy, not only you, from different hierarchy. So for that reason, you need to give it as a platform to others, isn't it? Like we are using different software, we are using ChatGPT, we are using what I call a web browser. So what we are doing, we are actually using that particular interface.
Okay.
So you have developed a model. Now that model will be used for its own purpose by the industry or by some other people. So for that particular means users, you need to provide an interface through which those users will use your model. They need not to know how the things are happening inside, but they will give their data and will take their output only. Okay, so for that particular purpose, you need to deploy your model. Okay, and inference is what, once the model is developed, there are two different parts are there. One is the training the model, when the model will learn to adjust its parameters to understand the inherent pattern in the data. So for this, it requires a lot of data. Once it has learned its parameters properly, such that the final error is reduced or satisfactory level, then we'll say that the model has learned. Now, once the model is learned, then we'll stop training it further. Now the model has now become ready for inferencing. Inferencing means you will give new data and you will get the output or the result. So this part is known as inferencing. Okay, so for this inferencing and deployment, we have also some tools like ONNX and TensorRT. Is it clear, sir?
Clear. Thank you so much.
Okay, so any other questions? From any participant? Okay, thank you. Now this scikit-learn, Dr. Banerjee will show you maybe probably today that how to use it, and you will find the magic of it. Okay, so no need to understand much more details of it. Just to understand what is the logic, you just know the name of the algorithm, how in which particular name it is available in the scikit-learn library. You just need to know all these things, and once you understand that how this algorithms works, you will be easily able to define its parameters, just separating commas or something like that. And you can, with the help of this library, you can develop any kind of regression algorithm or classification algorithm just in 2 or 3 minutes, not more than that. And if you use AI, so that's again means very easy. So I will request all the participants that just have the feel the power of coding with the help of these libraries. After this particular training, take a simple data, train your own models and check that how powerful it is. So once you are accustomed with this, you will understand its power and you will feel a lot of interest in it in future as well. So basically, for this particular scikit-learn, you need to provide tabular data, because most of the data in our real life problem solving, we get the data in the form of Excel, and Excel is nothing but a tabular form of data. Okay, so you will be using pandas library for accessing that particular data, and it is basically CPU based performance, CPU based analysis. It does a computation and high interpretability. You will be able to understand how the things are happening. So scikit-learn, like, you have different machine learning models like support vector machine, logistic regression, decision tree, random forest. So all these algorithms are there which you can use directly in your code. You need to get the data, pre-process it, divide it into training and test data, give it to the model from scikit-learn, the model that you are going to implement, get the result. Simple. No need to do that. Nothing more to do. And deep learning, I have already said. Okay, so probably it will be possible in the next week to show you that how to develop a deep learning model with the help of TensorFlow. So TensorFlow and PyTorch. So I will request all of you just to have an check in the internet, maybe in the Google or in any YouTube videos, that what are these things and how this works. Means how these things are used. No need to understand how these things works, but how these are actually used by the industry people. Nowadays, every industry are using this implementing deep learning, and for them TensorFlow is the best option. Okay, so it is ready for the production first, industrial scale, and it's deployment heavy. So it is for the industry people, such that they can very quickly develop any kind of deep learning model and deploy it for their own purpose or project. So this is basically means generated or developed by Google Brain, and after that it has become very means popular. It is also updated a lot, and it is also available for edge devices as well. So we call that to be TensorFlow Lite, like such that you can implement like in any kind of ML model in suppose Raspberry Pi or somewhere in other edge processors with the help of that TensorFlow Lite. And PyTorch is little bit for the researchers, those who would like to means devise their own algorithms, keep something, keep some portion of the model as it is, modify, improvise some other portion of that algorithm by his own algorithm. So some cases, if he feels that this particular part of the algorithm I will manipulate, I will change, or I will customize, so this PyTorch library will give that flexibility to the researchers. Okay, so this is for actually researchers, this library, but both of them does the same thing. It develops, it help you actually to develop deep learning algorithms or projects for you. And this particular PyTorch library was mainly developed by Meta. And Keras, as I have already mentioned, it is built on this the back in the back end we have TensorFlow framework. At the top we are having Keras API. So API means, you know, that application means interface. So here what it does, framework, easy to look. Okay, so again here at this level TensorFlow has made the coding abstract. Okay, we also no need to know the detail as we had to do in coding with C or C++, hardware level, or interacting that minor level of subroutine call or means function call or something like that. So that was reduced by or abstracted by this TensorFlow. This TensorFlow once again made more abstract with the help of this Keras API. So this is an interface we can consider. So it has become very simple syntax. Okay, with the help of very simple syntax, with the help of TensorFlow framework, you can develop any kind of deep learning model or projects. So it is very user friendly and ready for the industry. So it's very short. If I talk about scikit-learn, it is actually ideal for tabular data. Primary strength is very easy to use, and no deep learning can be implemented with this particular library. So it's simply for machine learning purposes, simple statistical algorithm purposes. And TensorFlow, you know, it is specially required for unstructured data, any kind of data, either it is a voice data, image data, or kind of a tabular data. So it is means so it can deal with any kind of data. So it is basically production scale. You can implement production scale projects with the help of this TensorFlow, and but it's complex. It is, and PyTorch, it also takes unstructured data, because if it is a deep learning, it should be capable of means dealing with unstructured data, which I have already mentioned in my very previous sessions, that we apply deep learning in the places where data are unstructured, incomplete, uncertain. So those are actually the areas where deep learning will be used. So it should be whatever model or framework we develop, those should be capable of dealing with this unstructured data. So, but it is really research flexibility is there. You can change the coding, you can customize it. Okay, and Keras, you know, it's basically prototype. It has the prototyping speed. It's very fast, and basically very less granular control. You cannot change much about what is default, what is set as default. Now there is always a question that whether, or it is a choice that whether I should learn coding or I should opt for no code tools, because, you know, with the advancement of artificial intelligence and Gen AI, a lot of changes is seen are seen actually in corporate industries. Okay, we found that many of the employees who are experienced may have like 15 or 20 years of experience. I have found in my friend circle also, they are actually undergoing courses from you means like Upgrad or Udemy or some other online courses to learn this deep learning, Gen AI, this kind of things, or going for a certification, because their industry now needs people who are means familiar with this kind of AI tools and algorithms. Okay, so for them, those who are learning or those who have to implement AI, so have not that much of time to learn whole things. So for them, I'll be suggesting that they may initially select for any kind of no-code tools like Altair AI Studio that I have already mentioned in my previous sessions. Okay, but for young professionals, researchers, or students, I will always suggest that you go for coding. Do not go for no code tools. Though there is no difference in performance as such, but coding tool or developing models using coding will give you a lot of freedom and flexibility and power in controlling and customizing what you are doing. Okay, so it's not a big deal if you do not know Python. I will always suggest that go for Python, though some other languages are also there which with which you can develop your AI tools or deep learning algorithms, but Python is the most popular and it is being widely used because it has something in it, isn't it? That's why it is widely being used. So just select one programming language only, go for Python. Okay, and it will not take much time to understand because you are all now mature and experienced. Okay, take on a project, have an AI tool, LLM tool, and devote some time, maybe 2 to 3 hours a day. And I'm quite sure within a month, if you are serious about, you will be in the position to create or develop your own machine learning and deep learning model. Okay, not be that much of expert, deployment ready, but for your understanding, for your own research, you will be in the position. Whatever may be your current situations, whatever experience you are having right now, coding now has become very easy and available for all of you. It is a tool, and we have to understand that how this tool works and how to use it. So no code tool for senior people, those who are have not much of time, but they have to implement AI in their organization. They have data they need to explore, but not much of time, not familiar with coding platforms. It may be MATLAB or VS Code or something like that. So for them, no code tools are very means can be a lucrative option. But for others, it's coding. So always go for coding because the power will be in your hand. Okay. So this is the conclusion from here. Now, Altair Studio is very easy. I have shown you that with the help of simple drag and drop features and functionality, you can easily train your own model and implement it and check the results. So this is what actually training and inference that I was telling sometimes earlier. You can have a look what this actually is doing. So training requires huge computational resources because it is iterative. Maybe a lot of different manipulations are required for this, customizations are required. But once it is trained, the inference takes less time and less resource. So it is faster. So training is the majority part. 80% or 90% is actually the training, and 20% is the inference you can consider. For inference, for training any algorithm, your main focus will be the accuracy. The error should be minimized. It should not overfit, neither it should underfit. Okay, so at the time, your main goal will be to achieve maximum accuracy, which is possible. That is the main purpose of training. People do not bother about the resources because the LLM models that are coming out frequently, is almost once in a month or 2 months, from Google, from OpenAI, from Anthropic. So they are bringing different LLM models for the public use or for our own use. But if you search in the internet that what is the training resource or training expenses for that particular training those models, I am quite sure those who have not searched yet, they will be stunned. They will be surprised that we are using so much of computer, so much of resources, so much of energy each and every day to train those particular algorithms or particular models. But whenever we are accessing it, our main focus will be the speed, because we will not use any particular interface which is slow. Yeah, ChatGPT or Google Gemini, all we are using, but all of them focus on responding to the user as early as possible. Because if at that particular time, if it get delays, people will lose interest and may switch to different particular tool. So for inferencing, my main aim is the speed, but for the training, my main aim should be the accuracy. And for deployment, I have not explored this particular tool, ONNX, but I found that whatever the basic study I have made, this is one of the means platform or the framework, Open Neural Network Exchange, where you can integrate any kind of your model, may it be developed using PyTorch or TensorFlow or scikit-learn, whatever it is, you can directly deploy it to any cloud server or any edge device or any mobile phone with a lot of ease. So this particular framework will help you to deploy your model to the public. Now, some myths are there regarding these frameworks which need to be removed before we proceed. One is frameworks are intelligent. No, it's not the framework. It is the algorithm which is intelligent. It may be TensorFlow, it may be PyTorch or whatever it is. Frameworks are nothing but calculators. Okay, intelligence comes from the data and the architecture. So it should be very much clear. Okay, and another thing is there, no code is only for toys. So people used to think, but nowadays there are many different tools which are really very sophisticated and powerful. So it's not for toy use. You can have a what I call a very good command in AI with the help of no code AI tools as well, and you can deploy it for use. You can what I call perform your daily or regular data analysis or prediction model with the help of no code tool as well. So used in the enterprise, manufacturing, healthcare, and finance for critical decisions, because all know the medical practitioners or the enterprise people from different backgrounds, economics, finance, or something. So they do not have much exposure or knowledge about the AI algorithms, or it should not be also, because they have devoted their time in attaining expertise in their own domain. So for them is actually that no code AI tool is very much important. But there is no to understand like that, no code tools are not powerful. It is for the only for toy making or something like that. No, it's not like that. Okay, and what we who are actually doing some kind little bit of experience in AI and machine and deep learning, we always think that you should not be stick to one tool. Okay, so there is a myth, you stick to one tool, develop your own expertise and exposure. No. This is not going to take you anywhere. Okay, so you should always appreciate which is good, which is accurate in the market. Okay, we may have some time of fascination because OpenAI has brought ChatGPT or this LLM the very first time for the public. So many people have their own fascination that ChatGPT. Okay, they have the ChatGPT has become a kind of a popular one, but that's because sometimes we are afraid, we are reluctant of changing from this OpenAI tool ChatGPT to Google Gemini, and some are more aligned to Google, so they want to means they don't want to leave Google. They want to stick to that Gemini. Someone fond of Anthropic, Claude. So, but every tool have their own pros and cons. Okay, so that's why if you would like to become a really a very good and efficient engineer or researchers, we need to learn how to combine the strength of these tools such that their weaknesses could be avoided. Okay, so and again, I'm telling you, using tool does not always means that you need to spend money. No, you have to, if you search properly, if you are well updated, you will finding that a lot of open source free tools, free APIs are already available, with which you can deal with any kind of complex problems that you will face day-to-day life. But whatever I am telling you, these free tools are very much suitable for your own research and development and learning purpose. But if you would like to do something production ready, then you may have to spend some money for API cost or something like that. So here my main purpose, means what I would like to say is that be updated, keep tracking what are those models coming in the market, okay, and what are their pros and cons. Check their benchmark performance results, check their reviews, and never be confused in switching to other tools, just to check and test that whether really those are very much fruitful or not. So do not stick to one tool always. So this is the main thing. So any question from this discussion from the audience? Any questions, any clarification, any discussion?
So far clear, sir.
Thank you so much for the response. You are always also welcome if you'd like to add something. Okay, so before I hand over my session to Dr. Banerjee, I would also like to discuss something more about this Python. So just very quick, because most of the things I have already discussed. The main power of Python, because I am also fond of Python, Dr. Banerjee is also very much fond of Python. So we'll always means we can be biased to Python, like many. So always remember that it is a main. Okay, any question? Yes. So that question will be answered in this particular session. Which is better for R and Python? Okay. So as it is means rightly mentioned over here, Python is the peanut butter to AI's jelly. So I will come to this particular answer for your question just at the end of this particular presentation. Okay, whether Python or R, which is better for you. Okay, so it is basically the glue, because it coordinates high performance C++ behind the scene. Okay, it works on C++, means like that. So, and it acts as a control room for heavy computation. So without knowing the minute details of the coding, you can perform high computation. So bridging basically human intent with machine execution. So machine execution part are taken care of C and C++, and Python takes care of your interface and your ease, and it makes it performs, it acts like a bridge between this. Okay, so it's a control room kind of a thing. And the undisputed backbone of AI, you all know that it holds almost 23.88% of rating on this particular index, and right now almost 78% of the organizations are using Python for their deployment. And you know, another advantage of Python is that it is syntax is very easy to understand, and it reads like English, allowing researchers to focus on algorithms rather than the semicolon. So those who are from this computer science or this IT background, they understand the pain of semicolon and comma whenever we used to write code using C or C++. But in Python, no need to bother of that. You focus on the code, the problems that you are trying to implement. Do not focus on the like what I call syntax or syntactical error. So basically, it is the like if I talk about AI ecosystem and the Python. So Python in the language which are actually used, and above that we have some library which are provided by some communities. Okay, so like NumPy, Pandas, Matplotlib, and above that we have a framework like scikit-learn, TensorFlow, and PyTorch. So this has made the whole thing possible. Okay. And it is capable of dealing with all types of data like integer, float, string. Okay, so as like in other, but using or dealing with this all this type of data, it's much easier, what I have found, using Python than any other programming languages. It also have their different data types which are very much useful, like list, dictionaries, JSONs. Dictionaries are nothing but JSON-like structures which is having a kind of a key and some values, something like that. So these are some specific data types, we can call the storage structure or storage types, which are easy to understand and easy to deal with. So Python provides that. And what I have found, if you just check the historical development or updation of Python community, if you search in the Google, you'll find that whatever the difficulties or the problems those were faced by programmers or researchers, this community provided all of them. So that's why it is big popular. Today we are facing difficulties. Be sure tomorrow community will be providing you something, giving you something. The largest community we have. And the defining logic is also very much important. So suppose if this is the flowchart at the left, you will check the coding of Python is very easy. Very easy. Nothing means those who can understand English, they will be also able to understand the code. Initially, you may not write the code, may not be able to write the code, but I am quite sure those who have the sense of logic and understanding of English, they can read the code and understand. At least means 80% of the code you'll be able to understand. So this is the power of Python. And basically, for building any kind of a thing, that it is a blueprint that is define a repeatable process. So you define a process once and reuse endlessly. That is a function, the concept of that. So with the help of this, you can normalize data, you can apply mathematical logic on it, whatever it is, and get the result. So defining a pipeline is very easy using it. You have n number of libraries. I'm telling you, thousands of libraries are there, and all from general purpose to special purpose. So from people from every domain can find their libraries from their own domain, which is actually required and which will make their tasks easy. And though for the new or the beginners, those who are learning to code Python, or they will be doing a machine learning project for the first time, for them, I would like to suggest that go for Jupyter notebooks, either from like Anaconda platform or from VS Code. So this Jupyter notebooks is again a very efficient tool. Maybe if time permits, Abhijit will show you that how to write the same code as Jupyter notebook. But Jupyter notebook is a kind of notebook. Notebook means what? We write comment, we do problems, we keep results. So this notebook, Jupyter notebook, is also doing like that. You will be able to take notes, you will be write the algorithms. Also at the same time, you will be able to write the code, store the results. So this is the best platform. Is once a screenshot is written. So here you can find that here you have written the note that what your this line is going to do. This line is for the code where you will write the code and run it, and the result will be displayed in the next are output window. So at the same time, you can write your notes, like the purpose of the particular code, write your code and take the results. So this is a very good interactive like what I call platform to write your code or develop your own machine learning model. So you can write the code in small chunks. Like normally, if you see any kind of deep learning like code with a full pipeline in VS Code or into a simple Python script, you'll be finding thousands lines of codes. So for the beginners or for the light programmers actually, which do not like heavy programming, so for them, those Python scripts maybe may seem that it's very cumbersome, complex, okay, but Jupyter Notebook will be implementing the things chunk by chunk, step by step. So it is like a page by page readability will be further improved. So I will always suggest that for the new, when if you are new in this particular programming or machine learning coding or development, go for this Jupyter Notebook for developing or creating your own problems. Why framework is required? I have already kind of said already, because without knowing the without using the framework, the things will become unmanageable and you have to work very hard to achieve the same thing. But if we have the framework already and if you can use it for free, then why you should not? So always try to check whether the algorithm you are going to develop, whether any suitable framework is available for that or not. If it is, then go for it, use it. Otherwise, you have to write your own code or function, whatever it is. So classical machine learning and deep learning I have already said, and the scikit-learn I have also shared that it is one of the like most powerful tool. Okay, so and it is having a lot of capabilities like pre-processing, regression, like models, clustering. Okay, then this is it is also capable of applying any kind of regression algorithm, any kind of clustering algorithm, classification algorithm under the same umbrella. So that's why it is so much powerful. And for scikit-learn, the pipeline is very easy. You import the data, import that particular library, instantiate your model, then feed the model and predict with for new data. So it will be in the practical class, it will be shown or discussed more detail. And already TensorFlow I have said that it is basically the engine behind deep learning. You no need to know what is actually happening inside. Only you need to understand its interface, how the things are actually working. So it is powered by Google search, you all know. So basically TensorFlow or Torch, PyTorch also in almost it works like in the form of sensors, because tensors are the storage structure for the data whenever you are dealing with this particular. So tensors are nothing but storage structure or data structure, you will be saying, for storing multidimensional data, like multidimensional arrays which are optimized for GPU processing. This is what is the power. Okay, so normal array lists were there, but tensors are made ready for GPU processing as well. So if you have the GPU from the tensors, data can be easily given and for processing by the GPUs. And it normally, both TensorFlow and PyTorch functions in the form of computational graphs. So for any machine learning or deep learning, it requires many computations. Okay, so all the computations are individually considered as a node in a particular graph, and so it considers that all operations as a graph, and after that it performs one by one all those particular operations. So data flows through these particular nodes in that particular graph, like water through pipes as it happens. So you can easily see that it is an example of a pipeline system where the input is given, suppose for example through a pipe, then add is an operation, multiplication is an operation, then is an activation operations are there, some other operations are there. Like in deep learning also, suppose here vector processing is there, here optimization, gradient descent is there, or suppose here you are using calculating the probability, you are also suppose multiplying two matrices. So different nodes are there, but this TensorFlow keep tracks of all these different operations very effectively and efficiently. And Keras, what I was saying, Keras is a kind of a steering. Okay, so if the TensorFlow is the whole engine, Keras is the steering. And you know very well that if we have to manually keep control of all the components of engine, so it will be very difficult to drive that particular car. But Kera, with the help of that particular option, you can simply, like suppose a model.fit x comma y comma epoch. So it is directly saying that you just fit the model which you have defined with x as like the input, y is the label, and you need to take 10 iterations. So it's very so simple. With a single line, you can fit a particular model to a particular data set. Okay, so this is the thing. It always also take care of gradient calculations automatically, session management, variable initialization, all. Okay, so while you just check on this particular slide, already I have said this, so I'm not repeating this. Now, which tool should I start with? So this is the decision making. Always we face we have to do. So for that particular purpose, we have to first check that what is our data. So if it is image, audio, or free text, then go for TensorFlow or Keras, because this is a very easy platform to do with, and these data are also very unstructured. But if the data is in an Excel sheet or table databases, and then I have to check whether it's we have massive database like greater than 1 GB or something like that. So if it is massive, then again go for this TensorFlow or other tools like that. If it is no, and if it comes under the normal prediction or classification, then go for scikit-learn. So this is the thing, and always thumb rule I am saying, always we are saying that go start with simple scikit-learn library. Okay, then only move to deep learning if the problem requires perception and massive scale. Otherwise, do not go for the same. Okay, so now to answer the question R versus Python. So for this, I'm telling you both of these programming languages are very powerful. Okay, but both of them, specifically, though I am very biased to Python, but I generally don't find any means limitation of Python. But R is specifically more suitable for statistical programming. So if you are from statistics and you need to frequently like what I call develop models, statistical models, and you need to perform statistical algorithms, calculations, mathematics. So for them, R is very efficient, and it is very like user friendly also in the, whenever it is the test task of like statistics. Okay, but if your goal is web development, like till deployment, if your goal is like what I call uh, object-oriented programming, modularized programming, or you need to like uh, work on different types of data altogether, like it may be image, voice, or something like that. You are developing a ensemble model kind of a thing. Your data are coming from different resources, from different sensors, and you like to like some data are coming from databases, some like means data are coming directly from different sensors, some are being downloaded from the websites, and you need to combine all of them and work together. In those cases, I think Python is the only option. I think Abhijit will be start with clarifying all this thing later, because he have much more exposure on these programming languages as well. Okay, so with this particular discussion, I would like to conclude my sessions today, and Abhijit will take over very soon. So before I conclude, if anyone have any question, then please ask me, or anyone to comment or discuss. Any questions from the audience?
So I'm part of. I'm a business person in one technical project where for some image recognition they are using something called YOLO.
Yes.
Which group is this part of?
Group means?
I mean is it part of the TensorFlow or Keras?
No, it's a library.
Oh, it's a library itself in itself.
Yeah. Yeah.
Ah, okay.
Okay.
It's not actually a library, it's a framework. It's a framework based on DL models. It's a DIT system. DIT system stands for diffusion models. The purpose of this particular the purpose of this yellow framework, which stands for you only learn once, is majorly to be broadly classified under as
you
Dr. Babu
you
was
only
saying,
learn once or loop once? I think it was loop once, na?
learn once. Look once also is fine, but it falls majorly under the classifier section. It is majorly a classifier, but it is also a multimodal system. It can also do OCR also.
Okay, thank you.
Another question from Kiran Srivastava that I would like to know: do we have any tool is available for data interpretation?
Yeah, there are many tools. There are many tools. If you are into a no-code
Interpretation.
segment,
Just
yeah,
let me ask that interpretation means what? What type of interpretation you'd like to do? Based on that, tool will also differ. Mr. Srivastava, will you please? Ma'am?
Is it audible, sir?
Yeah, ma'am.
Yes, sir. Good evening, everyone. I would
Good
like to know if any tool is available for data interpretation. Like if I want to do the analysis for or interpretation for a regression or ANOVA, exact when I'm writing what kind of problems I am facing, proper analysis I am unable to do. Like interpretation is not accurate. So I would like to know if any tools are available for interpretation. Hello?
Abhijit?
Yes, sir.
do I say?
Yeah.
Yeah. There are many no-code tools which are available for the same purpose. You can go with the most frequently used is Julius AI.
Okay.
Spelling will be JULIUS space AI. It is majorly provided by OpenAI itself, but it's mostly free. Mostly in the sense it does not take data above 1 GB, and it takes only tabular data. For ANOVA and all other statistical methods for the data analytics part, you can do that with correlations, heat maps. It will show you all those things. But if you can specify what exactly is your problem, then I can be more specific about it.
Like I have done the regression analysis, but when I have sent to one of the Scopus journal, there they have they said you have to interpret it like if it should be like if I'm saying it that R value, if I'm saying, then they are not satisfied with that. They are saying that it should be like positive to moderate. Those kind of wordings means I'm unable to do it. So for that reason I wanted to know if any tools are available.
Okay, so you want to have a linguistic analysis also. That can be done with Julius AI, but majorly it is done by the human itself who's doing it. So you will have to interpret your analysis, because analysis is quantitative. What they are asking is for a qualitative. Now, for a qualitative analysis, I don't think nobody is better than a human being. AI is not the right way. But still, if you want to do it, go with Gemini. Get your quantitative analysis data, feed it to Gemini, and ask it for a qualitative analysis, and it will be providing you the same.
Okay, sir.
I'll be showing you.
Yes, sir. Thank you, sir.
Okay, if you do not have any more question, then I will be happy to hand over the session to Dr. Banerjee. Please, you continue. Dr. Banerjee, are you there?
I'm here.
Okay, you start.
Okay. Is it visible?
Yes.
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 See, last day we were talking about OLS or ordinary least squares. We will go into the depth of it, but before that, I need to clarify some of the points or some of the questions that you are asking. Somebody asked, what is the better, R or Python? Dr. Thakur had rightly said it is all up to you. But I would say, from my own experiences, I have been using R seldom, not much. C, C++, C++ majorly, Java, Python, Ruby, etc. Out of which I will classify Python as a rapid development programming system. So if you want something, your boss wants something to be done or analyzed in a day or so, go with Python. If you want to build a robust, solid platform which will run for years, go with C++ or Java. But Python is something which is majorly revered as the go-to tool for AI. I would suggest if you are into hardcore AI modeling, you are into publications, stick to Python and not R, because R is not yet publication ready. It has got many statistical tools. It has got good interpretability, but the only problem with R is it is slower. It has got zero GPU your considerations. That means it doesn't look into your GPU hardware. Even if you have one, it has got low code compatibility. For example, your CPU, let's say, has 6 cores, it will only utilize only one. The other 5 is dormant. It has got very less freedom of modifying stuff, the modifying the inherent modules. So in a sense, it's almost like a proprietary system bundled to look like a freeware. Whereas Python is totally free. It's all up to you to how do you manage it. So my advice is for a beginner or anybody who is into publications, go with Python. I hope that clarifies. Now, returning back to your last session, we were talking about ordinary least squares. We said that we should have a particular uh, way of predicting what would happen in future depending on the historical data of the past. To do that, we talked about something called as OLS or ordinary least squares. Why least squares? Just a recap, least means to minimization, which is evidently presented here, which is we need to minimize the square of the residuals, the actual minus predicted, that is squared, and then we sum it up, and that has to be minimized. But what we did not talk about was how it is actually done. So today we are going to talk about the inherent algorithm, the mathematics behind it. Trust me, it's very simple. You do not have to be worried about maths and all. It's very simple. So we'll go with that first, and then we will be diving into how to code the same thing in programming. So first we'll go with OLS. Okay, so we see that we have these black points. These are our data points. This data point is here, this data point is here, and we have a straight line which almost makes a division in between the points such that all the points are in the
minimum distance from the blue line, that is my regression line. You will also notice that it's a straight line. So y is equal to mx plus c. It is not carved or something that short of. If it is a straight line, then it must be linear. If it is linear, then this OLS can be also termed as linear regression. So right now we are dealing with linear regression only. Now we need to know the maths of it. Maths is very simple. First and foremost, if this is our data, one moment. If this is our data, then what we need to do is we have price, quantity, and revenue in a series. Now what this says is take the X mean, take the Y mean. For our purpose, we are going to predict the revenue based on the price. So what I'll be doing is I'll be taking only the price and the revenue, put it into a new one. Yeah, I do not need this quantity. I'll be leaving it. And we have this particular series. One is for the price, one is for the revenue. What this equation says, take the mean of X and the mean of Y. So let us take another column. I'll go with Excel first, then with the programming. So mean of X. What is my X? I need to understand what is my X. X is the independent variable. Y is the dependent variable. The variable which is dependent on the independent variable. Which one is my independent variable here? Which one is my X? I'm asking just.
Price.
Price. Okay. So I need to take the mean of price. Then definitely mean of revenue should be taken, which is my mean of X. Y. Mean of revenue. Let me write it as Y. Let me write it as X. Now, simple equation is I have to take the mean and this one. So to do the mean, what we need to do, we need to sum it up by the total number of columns. As simple as this. So we'll go bottom down. And I guess I'm not good with Excel, but I will try my best. Equals to mean of, I guess, this columns. So it doesn't understand mean. Okay. I guess it understands average.
Yes, it would be average. Average.
So it understands average. Similarly, I can do the same for this, which is for these two. Now I'll be taking this, and I have these two values. Just the numbers, yeah. So my first step is done, which is take the mean of X, take the mean of Y. Next thing is, if you go down, step 1 of 4, the next step is you take a summation of X minus X bar, which is my mean, multiplied by Y minus Y bar. No need to panic, it's very simple. We'll go here and we'll copy this two on the side. We don't need them right now. What this actually means is X is 150. So you'll have to have X minus X bar. Here, let me write this as X minus X. How to write bar?
You can just type bar.
I can just type bar, or I'll be writing it my way. So this will be Y minus Y. Well, let this be bar. Now, this will be equals to What minus what? 150, which is A2, minus this one was the mean. This goes here. I got a value over here. You will notice that it is in negative. Now I'll have to do the same for all of them. I do not need this. I have to do the same for here. It equals to this one minus the mean. Mean is this. So I got a value. I'll have to do this for all of them. What we have done right now is we have taken these two things, x minus x bar and y minus y bar. But what it actually says is summation of this. Summation of x minus y bar into y minus y bar. So I need to do one more step here, which is my multiplication. If I do not do that, then there will be a problem. Sum of products and squares. I need to do two more things, sum of products and squares. So this into this. I'll go back here. Let me know when it feels confusing.
Dr. Banerjee,
Yes.
will you please check the formulas whether it is correctly copied? I think because for the rest of the rows, other than the first one, it is taking the next H3, which is blank. So it is 200
All
minus
should
200.
be H2, na? Everything should be H2.
Yeah, you can lock
You
this.
actually lock. You just write only there 211 minus 22. In the place of H3, at the top of the you just write 211.22.
Minus, you mean the actual value?
Actual
Yeah,
value you just give.
that makes sense. That makes sense. Correct.
Now drag.
Now I left drag, right. Excel has never been my forte. Now, here will be 2017. I hope this is right now. Now what we need to do is we need to multiply this into this. So what here will be x minus x bar multiplied by y minus y bar. Which is basically this multiplied by this. And we have all these values for x minus y bar and y minus y bar. Now the last step that remains is we have the summation point. Now regarding the summation point, we just need to add it up. I hope addition will be easier. There's a thing called auto sum. So we have this value. I'll copy this value. I'll paste it over here. So we have this summation, and we also need to do this x minus x bar and then uska square. So x minus x bar is here, so I'll just copy this up. This will be square, that to sum. So this one will be this into C2. Again, I'll just use my way. And we need to also have the sum of that. So auto sum. This is the value of the other one, which is summation of that. I know it will be boring for a while. Maths is never, non-boring. So let's say this is sum 1. Let this be sum 2. So we have got two independent sums. And what it says next is solve for slope. What is slope? We already said that there will be something called as a, one moment. Yeah, we have all these points are here, and there is a line in between. This straight line should have an intersecting point with the baseline. This theta or this angle is called as a slope, and this is called as an intercept. Why? Because y is equal to mx plus c. That is the equation of a straight line. We are solving for m. We are solving for m, which is my slope. We are solving for c, which is my intercept. So right now, after all these equations and all, we need to solve for the slope. First thing is to solve for the slope. So slope or beta 1, for example, in our case is m. M is basically the sum 1 by sum 2. So slope. Let us go over here and write the slope. What will be the value? Equals to which by which? Sum 1 by sum 2. Sum 1 divided by sum 2. And we have this. What does it specify? It is my slope. Slope means 7.671. What is this slope? Slope is basically this m. So we have m equals to, how much was it? 7.671. 7.671. Now we need to find what? Intercept. The intercept is found by, again, what is this 192.04 and this into this? We have already found out. The first x bar and y bar, those are a mean. So what it majorly says is, what was 192? Y bar. So y bar minus bracket, what is inside? Beta 1 into, what is this 342 is x bar. So we can write this as, again, y bar, which is y mean, minus, I'll go very slow with this. I'll write it down. So C equals to y bar minus bracket. If you look closely, this is this beta value. Where is the beta value? This beta 1. So this one will be beta 1 or my m. We have already found m as 7.671 minus, where was it? minus multiplication by 342, which is my
X mean.
x bar,
X mean.
x mean. So this one will be multiplied by, I'll write this as properly as x mean, x mean. Now what was our x mean? What was our values? X mean was this. Let me copy this. So we had an x mean of this value 211.22. So this one will be again written as y mean. I'll just put over x mean first, 211.226. My m was already found as 7.671. So 7.671 into this bracket. What was our y mean? Y mean was something 2057.5. So 2057.5 minus this. I'll write it clearly. This one will be 2057.5 minus 7.671 into 211.226. 211.226. What we have now is our exact C. When we have this M and our C, do we have the full equation? This was our equation, right? Y equals to mx plus c. Our notion was to find the values of m and c. Now we have these two values. We have c here and we have m somewhere over here. Now that we have two values, m is found as 7.671 and c is found something with that it will be finding. Now we have a straight line. Can we now draw the straight line? I'm just asking to everybody. So my initial goal was to find a straight line. Straight line has an equation, y is equal to mx plus c. We are going to do linear regression. Once we have found this equation, then everything is solved. Why? Because we started our session by saying AI is nothing but y equals to f of x. We do AI to find this and only this f. This f is more important. When we have an equation, we do not need to find any sort of AI based f finding. But when we do not have an equation which approximates y to x or x to y, then we need to find this value of x, f. F is a what? F is a function. Isn't y is equal to mx plus c is a function? We had no idea. We know that we need to have a straight line, but we have no idea how to formulate this equation because we did not know m, we did not know c. But with this OLS method, now we have both of them and we can plot them up. I'll go again one by one. First step was to find the mean of the x and the y. What is x? X is the independent variable, y is the dependent variable. Next step is to find sum of products and the squares. So sum of products of what? X minus x mean into y minus y mean for every single row. And then we need to sum it up. Similarly, sum of squares. X minus x mean square. The square is important. We already have said that least mean square. The square is important to negate the negative values. Now, when we have these two, sum 1 and sum 2 done, solving for slope is very easy. We need just to do sum 1 by sum 2, which is this step. Solving for C, that is the intercept, is done by this 192 is my y bar, y mean minus our beta value, that is my slope, into the x mean. I know it's maths, but is it clear? If not, I'll repeat. Just let me know. I can wait for hours for an answer.
Yeah, it's clear. This is quite interactive.
Good. Now, let's put some other values. We talked about the last session, we talked about outliers. Outliers are the items or the number points which are beyond the normal bias. It has got a lot of variance. What if these black dots are very close to each other? Makes sense. What if I put a dot over here? What if I put a dot over here? A dot over here, another over here. All of these are now outliers. Do the blue line, that is my linear regression line, closely follow the data? It has got nothing to do with the data now, because we have too many outliers. This point, this one, as well as this one will now suffer, because initially they were very close to the blue line. Now they are far off. I'll repeat. Most of these blue dots, those are my data points, are close to the blue line because they have a proper bias. I am introducing some sort of a variations by introducing an outlier. One outlier here, another outlier there, another outlier here. Now we see that the blue line has no idea where the other points are, and most of the points are very, very far off from the blue line. That is my regression line. My primary job would be to find out, is there any outlier in the data, and remove them, because we need our data points to be close knit. If they are not close knit, I will be losing a lot of data interpretability. If this is clear, I'll be introducing the same thing in our programming. Before that, one more step is to be done. As Dr. Thakur had been saying, that once you have your data, do not jump into modeling. This has to be done first and foremost. You receive your data, done. You need to do this data pre-processing. Once you do not do this, your data might be insufficient or not interpretable. We always say garbage in, garbage out. So your data is your primary source of bread and butter. So you'll have to make sure that is all right. So first step is missing value imputation. If there are any missing values, there is a row, there is a row, there is a missing row, then there is a row. What do I do with this row? If it is missing, what do I do? I already said, take the values of these three, do an average, rolling average, and put it here. Y3. Every single thing has got a question and an answer. Y3, 3 is called as something called as a window. I take 3, you might take 5, somebody else might take 10. Then what does it depend on? Why should I take 3, 5, 7? What does it depend on? It depends on, let's say, for example, you are analyzing a stock market data. You won't find for every single second the prices change rapidly. For that particular purpose, if you do a rolling window of say 100, makes no sense. You can then take 3 or 5 because your data itself is very close knit. But your doctor who is taking data of a patient's heartbeat, it changes. it changes very rapidly. In 3 seconds, it might be between 67 to 71. By numericals, that is a huge gap. It is not in decimals, it is in integers. You need to take a rolling window higher, 5, 7, 8, 10, that sort of a thing. Let's say we have one more data set where we have the price range being calculated of Nirma detergent powder on a shelf in a shopping mall. What sort of a rolling window do I need to take for a monthly data where one of the month is missing? Should I take a rolling window of 3 or 100? I repeat, there is a product, Nirma ka your washing powder on a shelf in a shopping mall, and I need to find out the monthly data of that particular item. I have got all the data except for the month of June. What rolling window should I have? Should I have a rolling window of 3 or the last 18 months? Last 3 months should I take or the last 18 months?
Rolling window 3, average of 18 months.
Last three, yeah.
Last 3.
Why? There has to be a justification behind it. There has to be a logic behind it. What is the logic behind it?
It will take into account the if there is any cyclicity or seasonality in sales.
Correct. Then why not take the last 18 months? Why not take the last 6 months? Why take only 3?
Good question. Sorry.
No, there has to be a thinking. As I said, the logic behind it is how much does it change with time? Seasonality. As sir was saying, seasonality. I'm saying the month of July is missing. There is January, February, March, April, May, June. Is that a full season? No, we have 2 seasons there. So if I have to take the seasonality inside this, then I will only think of the portion where there is a chance of movement in the price range. Obviously, it is washing powder. It has got no seasonality. Had it been any other product, say for example ice cream, and I'm losing the month of July, there wouldn't have been any problem if I take from the month of January to May and then take a average of that. But had this been something else, I would have to take a larger amount of months. Example, I shouldn't say this, but cigarettes. Cigarettes, I should be taking 18 months, 20 months. Why? Because there is GST's changes, there are other budgetary changes. I should be taking a longer, because I know prices do change with time frequently. The word is frequent. If I know the prices do not change or the numbers do not change frequently, I should be taking very few window, that is 3 or 4. If the numbers change frequently, I will be taking a longer window. Hope that makes it clear. Somebody was from the business background. If you are into business and you want to have a prediction of your data, then do take the rolling window higher if the product or the numbers change frequently. Hope that makes it clear. The first thing we need to do is missing value imputation. If there is any missing value, we need to impute it. Then there is duplicate row removal. If there are any duplicate rows, we need to remove it because that will be erroneous. Third thing is outlier removal. We were already saying that had I introduced a outlier here, here or here, this deviates the values of theta and c, that is my slope and my intercept, and my predictions are all wrong. Since my objective was to put all these data points very, very close to the blue line, and now they are very away from the blue line. They are very far off from the blue line. So it doesn't make sense to keep all this 1, 2, 3, 4, 5 points on the top. We need to remove them. So outlier removal is very important. If you know there is an outlier, then there is feature engineering. Engineering we talked about. For example, we have a sales data and we have got date. The features that we can engineer from a particular parameter is called as a feature engineering. From my date, I can infer whether or not it was a weekday, whether or not it was or which day of the year, week was it, what month was it. So many things can be referred from here. Then there's product. We see it is written over here watch, but can I infer something else out of only this data? Any feature engineering that can be done? Not much. But what we can do is, you can see from this particular thing that here it is written as watch, category is accessories. But for numbers, for engineers, for mathematicians, for AI and all, in short, for computers, linguistic has got no meaning. The words have got no meaning. What if I can transform them into numbers? Let me see how many categories are there. I can see accessories, and I see bags, and I see clothing, and I see electronics, shoes. How much? How many was it? One,
Five. Five.
5. So let's put every single item, give or every single category a number. Let's say accessories is 1. All of them will be 1. If it is accessories, then the number is 1. So all of this will be 1. I guess you get the idea of it. Bags, it will be definitely 2. What we are doing is we are doing a manual classification by quantifying each and every single classes. And now if I do this, bags was too small. Bags. I'll not go with the rest. And now if I go with all the classes, I will have only numeric numbers. I can do the same for product also. Be very careful while you are doing this. Humans make mistakes. Mistakes are to human, to err is to human, but AI will take the error otherwise. Example, there are bags. No doubt there are bags. What is this? It's not a bag, it's a BGAS. It should have been BAGS. Such type of human error or data cannot be interpreted logically by any AI system unless and until it is intelligent enough, or like an LLM or so. So one of the primary criteria of your data should be go through either manually or through an LLM like Gemini or ChatGPT, whatever it is, to figure out if there is any linguistic error in your data. That is very, very important. Now that we have all these parts done, we have quantified it, we have done everything. This particular nomenclature of saying that category accessories will be 1 and this one is majorly called as, we have done what? We have encoded a language into a number. So we have labeled by encoding. So this is called as label encoding. I'll go with the very simplest one, which is this. There are others, one hot encoding and all. Forget about it. So we have, what we are doing right now is we are doing label encoding. We have taken a label and we have encoded it into the numbers. How does it make any difference? Difference is, had we not done this, we had to exclude product and category from any sort of regression modeling. But when we have done this, we can easily use them up. Now we have more data. More data means more insight. In business logic, the more the number of parameters, it is absolutely fine, just not redundant ones. Going back to the other one, what we have left is exploratory data analysis. That is fine. We have done feature engineering. We have done the level encoding. Had there been any other feature, we could have done that also. Am I missing something? Yes, we are missing particularly one independent thing, and that is called as dimension reduction. Feature engineering will introduce more features. What if I have more features, immense number of features, and I do not want them? Then I need to do dimension reduction using a thing called as a correlation analysis. These are heavy jargons, but in the end of the day, it only means, do this parameter matter? I just need to figure it out whether or not any parameter actually matters for the prediction. As I was saying in the last session, that the size of the pencil a student brings to his class doesn't actually interpret well or is relative to his or her n-term numbers. So that thing is irrelevant. We need to just make sure all data parameters should be relevant. To do that, we need to have a correlation analysis, whether or not any parameter is related to the end goal, which is my target value. And after doing that, we need to do the exploratory data analysis. This will provide correlation. And once we have this, we can do this dimension reduction. So up to this 1, 2, 3, 4, it's just straightforward, top to bottom. Jump back to exploratory data analysis. We get correlation values. Then we do dimension reduction. I repeat, 1, 2, 3, 4 are in sequence. We'll do them in sequence. We'll stop. We'll jump to 6. And then we will be doing exploratory data analysis. Then we get correlation analysis. Once we have that, we again do dimension reduction. Somebody might be saying, well, why don't you do this exploratory data analysis first and then do dimension reduction? Why is it at number 5? It is at number 5 because there is somebody in the loop known as a human being. We usually can interpret a data by at least looking into it. We do not need to go into this exploratory data analysis first. We can easily figure it out which parameters are needed and which parameters are not needed. A dental surgeon will not be looking into bladder ka kya failures hai. He will be looking into the dental properties only, but the data might have all the health numbers of the particular patient. So domain expertise is somehow we miss or we overlook, but we should put our emphasis on your domain knowledge first. As a human being, we can easily interpret which particular parameters are needed, which are not. So this goes in number 5, and then we have exploratory data analysis. Am I clear with this or am I going fast? Is it okay? Okay.
Yes.
Now, since we have done OLS in Excel sheet, we will be doing the same using a program. Now, as Dr. Thakur was advocating a lot about Python, I'll also do the same. Stick to Python if you are from a business background or you are a scholar who is not into direct C++ implementation. And I'll be very blunt with R. Forget about it. R has no place in a proper data analysis workflow as it is hyped. It is too hyped, but it has got no particular advantage over any other programming language. In fact, R and MATLAB will go extinct, and somehow Python will still remain, as well as C++. C++ is also one of the best languages not one of the best, the best. Python comes at the second point, but C++ is not for all. I love it, but is not for all. Now, we'll be doing the same with code itself. I'll be very slow with this. First thing that we need to do is, as Dr. Thakur was saying, we have frameworks, we have libraries. And I also said that Python is a rapid development platform. So if you have to write everything from scratch, it is contradictory to the intuition of doing stuff fast. So what I will be doing is I will importing a particular library.
Sir, can I interrupt for a minute?
Sure, sure.
What is this? What is this editor? Which editor is this?
It's a VS Code. VS space COD code.
VS Code. VS underscore code. Is it?
Not underscore. VS space code.
COD.
COD code. Yeah. I'm not sure whether I should have started with this because.
Nowhere it is written which screen, which editor it is. So people may find it difficult to nowhere you have written that.
I'll make it clear.
Anywhere. Yeah, please. Is the editor if you put then people will understand.
Yeah. Wait a moment. Editor.
Is it
freely
downloadable from internet? Is it?
It's a freely downloadable from the internet. You can use any other editor also. I am acquainted mostly with VS Code, so I'm using it. But as you have rightly said, or I can feel it right now, that VS Code is actually not for beginners, but you should start with it. If you haven't written a single line of code anywhere, anytime else, instead of starting your coding journey with a simple, easy to use code editor, I would suggest to go with VS Code. Yeah.
Can we go with Jupyter Notebook? Because they can use Jupyter Notebook in Google, like Colab kind of a thing, also in VS Code, also in some other. So whatever you're doing, if that can be demonstrated with Notebook, so it will be very helpful.
Sure. Let me go with Colab. You'll see that I
don't need to install anything.
I'm going with Google colab.google.com. I'll be writing it down. You can also use one more, which is this. Is it visible now?
Yes, it is visible.
Instead of VS Code, you can always go with the Colab. It is free. It is on the net. So it's a browser-based thing. You can go with that also. Once you're there, create a new notebook. It will take some amount of time to free up spaces and all. Now it's here. You don't need this. I'll be typing it fast. Is it clear now? Is it visible and clear now?
Yes.
Okay. So as I was saying, we need to import a particular library called as a NumPy. Numerical Python. Another one should be used up is pandas. Now, if you look very closely, what I've written is I have imported NumPy, fine, import space NumPy. Nomenclature is very simple. But instead of pandas, simply import pandas, I've written import pandas as PD. So I have given pandas library a name because every single time I will be calling the pandas library, I might have to call it pandas do something, pandas do that. Pandas is the big name, so I just shortened it up. Similarly, I can do the same thing over here as NP. So import numpy as this, and I will just move this out from my window. Give me a moment. Yeah. So now I have imported that. Now I need to pass on the file. I was thinking this is not the file. This is the file. There was a file we were concentrating on, sales data. So how am I going to do this? I'll just go to files. If you click here, you'll get the files. Wait a moment. Now you can drag and drop your files. Yeah. Warning is all right. Now we have a files here. How do I import these files? It's a CSV file. CSV file is basically normal file structures. What I will do is import this particular CSV file. I need to import the CSV file or read this CSV file. How do I do that? What is the file's name? Sales data.csv. And we know that we can do that by simply writing data equals to, we need to read that thing. So PD, as I said, we nomenclature is PD dot read dot data CSV. But there is a problem. What is the problem? This data.csv, we are only concentrating on the category called as accessories. What is the name? Accessories. So I need to filter this out. When you are working as a business operative, you need to filter things out. So I have to first filter things out, which is filter by category equals to accessories. What was the name again? Accessories. You will see data and category accessories is done. Fine. Now I need to show you the data. Show the data, which is basically print the data. Now I'll run this. No such file. Acha. My name of the file was sales underscore data. We have the data only for the accessories. Now, the primary thing that we need to do is, based on this price, we need to go with the revenue. So in the next block, see, I'm just writing another code block. The first thing that we need to do is find out the mean of the X. So I'll be writing this as find the mean of X equals to, which one is X? The price. So price mean equals to the sum of the price category, or you can simply write average. NP is numpy, np dot mean data price. What we have now is the mean. That is our mean. Does it match with the one that we have found? Where was it?
No, it was 211 point something, I think.
It's on it is on Excel.
It was on Excel. Yes. It was here. 211 point something. But we did for which categories? Did we do for price? The mean was 211.26 and I'm getting something else here. I will not blindly believe in Excel. This is right. Whatever this is, it is right. Because this will not do any problem. Now what we have to do is, second step was find the mean of my Y variable. Y is my revenue. So revenue mean is data revenue. And that is this. What was the second thing? I had to do with summation of X minus X mean and Y minus Y mean. So find
Dr. Abhijit,
are
I
we
think
running out of time?
I think the data is not matching because np.mean, it says data price. It should be sales data. Then I think it may match.
No, because the name of that particular thing is called price.
Okay.
It has to be price. There is no sales data. I'm
Okay.
not sure with Excel, but whatever is here is absolutely right.
Yeah,
In
we
Excel
Maybe,
believe,
formula,
maybe
formula is wrong somehow, but here it is
Yeah.
yeah, we believe this.
because I believe in codes rather than Excels. Because Excel is where I'm writing my own equations, I'll do mistakes. Maybe I took less number of data for accessories, or maybe I did something else. Wait up. Yes, what I did was I did not
The
filter
data
by
was taken
accessories.
less.
Yes, I did not filter by accessories. I took it for every one of them. Accessories, bags,
Yes, the whole one we have taken for clothing,
Yes,
for watches and
yes.
everything we have taken.
Yeah, we did not take the filter. Had I taken the
Yes.
filter, then it would have been
Then it would have been matched with the coding number.
correct. So now we have done the filtering, and that's the biggest thing. Now for OLS, what we need to do is find sum1 and sum2. What is sum1? Sum1 is no. Sum1 and sum2 is not that. Whatever it is suggesting is not that. Sum1 is summation of np.sum bracket of what? X minus X mean and Y minus Y mean. How do I get that? So first I will be just making sure that is all right. I'll be very slow with this. X minus X mean. So I have to clearly write it down. So X minus X mean. I'm just writing this thing up. X minus X mean bracket, another bracket, Y minus Y mean, and I have to take the sum of it. So sum and this. Now, if I say sum1, first it will do this np.sum data price minus data mean into data revenue minus data mean. So it is my sum1. What will be my sum2? Similarly, sum2 is basically my summation of X minus X mean. So sum2 will be that. Now we have the two independent sums. These are my two independent sums. And square. It eventually found out the square, which I did not write explicitly. Good. Now that we have these two sums, what is my slope? Slope of the straight line is basically sum1 by sum2, slope equals to sum1 by sum2. And what is my intercept? Revenue mean minus slope into price mean. We had put up a bracket here, which is also right. I mean, you should be doing this bracket thingy. Now we have a this two. Now if I want to plot this thing up, I need to have to import two more libraries. One more library is enough. Import matplotlib. Remember this matplotlib dot pyplot as plt. Now plot the data points and the straight line or the regression line. We have this independent data points. As you can clearly see that if I have to put up a point here, does it make any difference? I mean, what difference does it make? We have price as well as the revenue. By your data points are not actually showing much of a curve here. What can we do to make sure it operates? What I will be doing is, let me show you one more way. We have imported the sales data. We have taken only the category accessories. Now we are taking the date, the month, and the year. Why? Why we are going with the second one? Because if I take only the price, I see a value like this. I cannot draw a straight line. What does it signify? This signifies I need more data points. I need more parameters. Only the cost or the price is not sufficient. So what was the correct way of doing it? The correct way of doing that was known as this feature engineering. And as I was saying, that feature engineering can be done with the date also. We can infer the month, year, and all. We'll be going with that first. We took the sales data date. First, we took the date. Go very slow. We took the date. We inferred the month, which is a feature engineering. We inferred the year, which is also feature engineering. Aggregate sales by month. All the sales of the month is aggregated once, because in a month there are many. Prepare data for modeling. I took all the months, month sum, then sales sum. Then we have the data frame. Once we have this data frame, we can show this as sales forecasting model with your OLS. On the top, we were doing the normal OLS way. Dr. Thakur was talking about something called as a scikit-learn. Here we have imported a thing called as a sklearn of linear regression. You need not do anything with OLS, but you need to understand how it works. Once we have all this data, what we can actually do is these two lines. For the linear regression, for people with business background, instead of doing all those equations with OLS and then stuck with a image like this where we do not have a data point, go with normal this linear regression and then fit the model. Let me run this thing up, and what sort of results do you get? Let me see. File is not found. Okay, fine. A moment. Immediately we see all these plots. What are these plots? I'll be sharing this. I'm not sure organizers have any modality of sharing the code or not. Is there any way of sharing a code?
Mr. Datta will be able to say that, but I think you can share. We can share him to Mr. Datta, and he will be sharing with all the participants. Otherwise, this meeting is also being recorded, so they can also check anytime.
But I'm
Yes.
going very fast. I need to share the
Yes, sir.
code, right?
You can share the Colab link.
Colab link, that would be a breach of my own privacy. I'll be sharing by zip files only. Okay, I'll figure it out. We now have the historical monthly sales. I repeat, historical monthly sales. I've aggregated by month. This is January, this is February, and then the sales of the independent month. Then we have the product performance. Out of those accessories, there are other products. We found out smart watch is 57 point this. These are called as the business insights. We are taking into all the business insights through a simple code itself. How many units sold? Now, with these visualizations, I'll go into the visualizations. Now we have business insights and forecast. Base sales is average sales. Monthly growth rate is this. Base sales is this. January, how much? February, how much? This is everything is already expected quarter Q1 next year revenue. We are interested in this. We started with OLS or regression. This particularly says expected Q1 next year. If I have the values of all the year of 2022, how do I project or forecast the values of 2023 Q1? That is done by this linear regression. How? I'll be very blunt and I'll be very slow with this. We now have a simple y equals to mx plus c. We solved for m, we solved for c. Do I not have a proper equation now? Now that I have an equation, in the month of, say, January of 2023, we have data of only 2022. What do I have to do? X is, I can put up the number, I will get my y, because y is my dependent variable, x is my independent variable. I'll put any number here, I'll get the value of y. So what should be my value of x? All I have to do is put a number here. Exactly that's what we are doing here by putting the value of the 2023 cells by projection. These are the trends. I'll be showing it through here only. I guess I can. Is it visible?
Yes, it is visible.
Yeah. Your forecasted cells is on these three dots for the year 2023. This is 12th month. This is 13th month. This is 14th month. There is no 13th month and 14th month. That is accurately to be said as the January of 2023 and the February of 2023. What problem do you see? OLS, linear regression, mathematics, everything is done. What problem do you see from this graph as a human being, not as a statistician or as a as a business analyst? What is the problem from the left hand side of this graph? I just need your opinion. Is it right? Is it all right? Does it feel right?
Absolutely not.
Absolutely not. What is the problem? What could be the problem from a human perspective?
I mean, there seems to be no pattern
Exactly.
between the left and the right. There is no
Exactly.
similarity in pattern.
Yeah. We see the cells grow here, then it fluctuates, then suddenly it goes down. Then my trend is absolutely should be going down for the next 3 months. Why on earth is this going a progressive trend on the next 4 months? That too very high. That too very high than the last few months. The reason is, as I said, garbage in, garbage out. What we did not do over here is we did not take the uh, data and normalized it. We missed one point, one single point where both the scales are absolutely different. We missed this outlier removal, feature engineering, everything is all right. What about the last day we talked about something called as scaling? If I had scaled the data, it would have been smooth. We talked about normalization. Had I been normalizing this data, this could have been smooth. But that too wouldn't have solved all the problems. The major problem and the the beginning of your next session is what this did not solve was primarily because we used something called as a linear regression. The word linear do not fit for every data. Your data itself is not linear. I cannot put a straight line. If I cannot put a straight line, why would I want to put a straight line? Why shouldn't I draw something like this? I mean, one curve. So instead of a linear regression, what we should think of is a polynomial regression or a non-linear regression. Had this not been a straight line, had this been a curve, it would have fitted more accurately. So after all this linear regression talks, we come to one single conclusion, two or three conclusion. Number one, read your data as a human being. Do not directly feed it to an AI. There are linguistic problems, solve it. Go through all these data pre-processing steps. Do not miss any single one of them. Every one of them is important. After doing this, number three is use your best judgment whether to find out or to judge that data is linear or not. Is price and revenue is always a linear function? If I increase the price, my revenue will increase. If I decrease my price, my revenue might increase or decrease always? No. If the answer is not always, then you should not use linear regression. We should be using polynomial or other regression types, non-linear regression types. To the end of the session, we come to a conclusion that we understood what OLS is, we understood what linear regression is, we also understood when not to use linear regression, when to use polynomial regression or non-linear one, which I will be covering up in the next sessions. Am I clear with this? Have you understood?
One last doubt for me. How will
Yes,
you
sir.
find out duplicate rows? You will be able to find out only physically. Is there any method?
No.
Duplicate
You can do
rows.
that. No. You can do that easily using a Python. Use code for all your mundane jobs. Finding things physically is not right. I'm just showing you for once. Wait a moment. Problem with this collab is very hard to read, for me at least. See, basic data quality checks. First one is missing value. You need to find out the missing value, which is done using these two lines. You will see only the one thing. You will see only one thing over here. DF is the data frame, and then there is a word called as is NA. Is not number, or is NA, or is null. So is NA, and then I'm finding the sum. What it actually does is it finds all the rows or the sum of the number of rows where there is no values. Then what it does, it will, you can actually do this rolling window thing, or you can delete them. Similarly, duplicate. DF, your pandas framework already has a function called as duplicate. It one single line will find it out. What you can do with that is you can remove this. You do not need to do it manually. Any other
It means that
questions?
the sorry to disturb, sir. It means that this duplicate and missing value column is already in this coding or in this format.
In
What
the,
you tell, we don't have to do extra coding method for that to find out this duplicate thing.
no. It's already inbuilt with the pandas library. You need not to do anything around it.
Oh.
Any other questions? And I also need to know how to share this codes. Any other questions? Because I got to leave.
Sir, can you share that bar chart somewhat?
Yeah.
Code and the data set also. If you
Yeah. It will be with the data set.
And is there a method to share that visualization of the OLS, the step-by-step method?
Yeah, sure. That is in the code itself. I will be sharing the HTML file also.
Awesome. Thank you. Thank you so much.
Sir, I have just posted my mobile number. That's the WhatsApp number. You can share it, sir. Banerjee, sir.
Okay, then I'll be sharing a zip file then.
Yes, sir. Yes.
Take.
I'll follow.
Okay. Thank you. Thank you so much.
Thank you, sir, for the wonderful session. So today we're done this weekend, and next 2 sessions will be in the follow-up weekends. Thank you all the participants, and have a great evening.
Thank you. Thank you very much.
Thank you.
Thank you.
Going off.
Thank you.